Welcome to this video session. This video session is on final year project, and our final year project is on effective usage of iris code in real-time surveillance system. Before going to this project, I will introduce myself Shrikar Singh, and my team members are Pavithran and Vigneshwaran. And our project guide is Mrs. A. Marieda, Assistant Professor of Computer Science Department. And before going to this project, let me discuss about existing and proposed system of this project. Iris code, I think you all know about iris. In existing system, iris has been used as convex polyhedron cones. We convert iris images, 2D images into 3D images, where it takes more time, where converting this mathematical process of 2D into 3D images takes larger time, and same way the processing of iris image is also very high, and whenever we store iris images, we need more space for this iris images. These are the two disadvantages of iris in existing system. But iris is the most unique feature where 10 million people have single iris, so it is unique. And in proposed system, we have overcome all this. In grayscale conversion, we convert the colored image into black and white, where we can overcome the eye infection problems, where eye infected person again goes into this iris scanner. He can scan his eyes without any exceptions. And next one is pupil detection. We overcome convex polyhedron cones in terms of pupil detection. In pupil detection, we calculate the radius, and calculating this radius, we are not going for convex polyhedron cones. We are calculating the radius of the iris, and by the help of the iris we can easily wrap the whole iris as a circle. This is the easiest way of calculating iris, and by this we can easily overcome the partial eye opening, where in convex polyhedron cones we cannot able to calculate the partial eye openings. And moving on to the grayscale conversion, this is how we convert the grayscale image. And this is how the pupil. In this pupil, we are not going to calculate the whole pupil, just the marked part is shown here. This pupil is going to be calculated. And next, the partial eye opening. As I said before, we need not to require the whole eye to calculate. Just the radius of the eye is used to be matched. By this, we can easily wrap the whole circle. Coming to the architectural diagram of this project, first of all, we need a iris image through this iris scanner, and we convert the iris image into the grayscale image, and this grayscale image is again sent to the edge detection process, where edge detection process is used to calculate the edges of the iris. And this, after the calculating the edges, we need to detect the pupil. For this pupil detection, we use several algorithms like canny edge detection, and in this outer circle detection and inner circle detection is of pupil is detected to calculate the iris. And the main key feature of project is localization and normalization, where we calculate the iris in terms of iris patterns inside the eyelashes, and the other part of the eyes are being removed, and self eyeball and the iris is being stored. And in normalization part, the iris is unwrapped into a strip. In the strip is being divided into 16-bit cells, and the 16-bit cells create the 16-bit iris code. This iris code is being used in any real-time surveillance system. Coming to this project, we have overall 8 to 7 modules. First one is image conversion. Why we go for image conversion is we reduce the processing time, where a colored image has more different color values. For this purpose, we convert the colored image into black and white image. In black and white image, we use only 2-bit cells. One is black and white. By this, we can easily calculate the image. By this help of, we can easily draw up the image. For this image conversion, first we get the image, and we get the get dimensions, and we map the intensities, and last we get the grayscale image. And next one is median filters. So coming to the next thing is edge detection. We use scan edge detection algorithm for finding edge detection. For finding edge detection, we use median filters. Median filters, the process of median filter is nothing but it smoothens the image and it clearly find out the edges of the images. By these edges, we can clearly detect whether the eye has a pupil and whether the eye doesn't has a pupil. So this kind of things can be mapped in median filters. After this median filter, first of all, grayscale input image is given as the input, and then pixels are being get through this input, and we remove the noise from the image, and next we find the clear edges of the image, and this will be sent to the pupil detection. In this pupil detection, we exactly map the pupil. If your pupil is not being matched, your image will not be processed. Your pupil should be straight away given as an input. For this, we calculate inner and outer pupil. This is how the inner and outer pupil is being detected. And the normalization part. As I said before, the normalization and localization are the key features of our project. In normalization, what we do is we unwrap all the other part of eye and we crop the iris part, and we unwrap this iris part into a strip, and this strip is used as for processing iris code. In this feature extraction, we remove the features, and this is the generation of iris code. During normalization, we get the iris strip. This is that iris strip, and in this, with the help of this iris strip, we divide this iris strip into 16-bit cells. Each cell is mapped into 16-bit iris code. This 16-bit iris code is being processed as in terms of threshold values, and coming to this iris matching, whenever we get the same process of iris, first of all we get this iris and we convert the iris code and we save in the database. And next thing what we do is, again a person get into the system and he scan his eye. Again the process is done in terms of iris, iris is being scanned, and again iris scanned image is being processed and it is converted to iris code, and this iris code is being matched. The existing iris code and given iris code being matched in terms of XOR operation. The XOR operation maps these two iris codes. Whether the bits is true, all bits will be as 1. Whether this bits is false, all bits will be converted to 0. So whenever we have the correct iris code, we get authenticated. Okay, let's move on to our project. In our project, welcome back. Before going to the project, let me tell you some of the things what I have used in the project. And I have created this iris recognition system using Java platform with the help of NetBeans IDE 6.9.1. I have created two packages. One is bank locker and another one is iris recognition. The main project is being here iris recognition. In the secondary one is bank locker. You can use any one of your real-time surveillance systems like Aadhaar card, like banking system, like ticketing system, your passport, visas, etc., etc. Wherever you need a high security, you can use the iris. I have used the banking system. For this I have chosen Axis Bank, and when you go to home, your home page is being displayed here. And for a new user, you should click on the new user and get registered with the iris. Iris is nothing but your details, and your iris image is being merged and it is being stored as your detail. For this, give your email ID. And your city, your mobile number, and your PAN number if you are given as and your account number, your PIN number. So if any one of your field is not been correct or your field is wrong, you will be authenticated as error. So please make of correction on it and go through it. If your details is not having any errors, you will go on to iris recognition system. This is the main project, and to enter in the system, please, click on actions, scan an eye. So please scan your eye using your iris scanner, and your image, where your image is stored, is being located in this file chooser box. And if your eye has been chosen, click on your eye and give your name, sample user, and this process will take a couple of seconds. As I said before, convex polyhedron takes more time. In this process, as you see now, just couple of seconds has been taken, and this one is your iris image, and the iris image is converted into grayscale initially, and this grayscale is again converted to edge detection process, where your image is being smoothened to detect your edges of your eye. After detecting your edges, your pupil has been detected. So exact pupil is being detected here. So this indicates that your pupil is being detected. If your pupil is not detected, your eye is not being scanned properly. So better scan another time. Okay. Next one is scanning edge detection, where your iris pattern is being mapped here, and another one is pupil radius detection. Here your pupil is also being detected. So you may think that I have shown you only images, where this images is not being converted into code. Yes, because this is a highly secured system. Your iris code will not be revealed in the user panel. So I will show you in the developer panel. So whenever you whenever you convert the colored image into grayscale or grayscale into edge detection, your images is being converted into 2-bit pattern. So for this, for existing user, we are going to match the eye. The eye which we have given previously, we are giving the same eye. So if the eye is being matched, you will get into the main account. And same thing, I will again match your eye. If I match incorrect eye, you will be authenticated as you are invalid user. So by this way your eye has been authenticated. And to view your details, you can again go into system and put your account number, and you can view who are the user enrolled in the system. So the sample user and the account number gender I have given here. So you can view the details here, and then we can go into the coding part. So as I said before, we are using SQL for backend to store data. Whatever the data has been stored is being replicated in the database. So I stored my database in this detail table. So you can view here, the name is Sam, and where the image has been taken, the image source and the image name. The iris code which has been generated is being marked here, and final one is your basic information which have merged with your user bank account details. Which one is your this one, mobile number, email ID, and you can note here like max account, max and mean. Max is nothing but your iris maximum intensity values, and here your mean will be, the max and mean will be your threshold values, where you having this as a reference code, to generate iris code. This one is your iris code 0.1630691117997222368. This one is iris code which will be storing in your database, but this will not be revealed in your real-time surveillance system. As I said before, you can now close your real surveillance system. Okay, now you are gone through the system. Now I will show if any one of the other images has been given, what happens is it will not be taken. Suppose I am giving an okay. If you misbehave and if you are not giving your eye and you are giving some other images, like any other images like buildings or any, you are giving such images and the system will not be taken this. You can now see that your image is not being processed here. So by this you can understand, yes, you have that iris and the pupil radius not found, so you are not given the proper iris image, so this will not be saved in your database. Okay, so this automatically indicates that whether you are given a correct eye or you are given any other images. If you give any other images like this, it won't take, because we calculate the iris in basis of radius and edges and iris pattern, so it will clearly detect whether the image is eye or any other else. So it can easily detect your given image is eye or not. And then we can close this one, and then we move out to the main coding part.